has a advanced degree in the Doctor of Ministry in Apologetics, like Phil Fernandez has as well. But at present, he is the pastor of a bilingual church in Miami. So his family hails from Cuba, so he can speak Spanish and English fluently. And he often actually goes to South America to speak on apologetics topics down there because of that. And so, as well, he speaks for Reasons for Hope. We've had Carl Kirby and Frank Figueroa here before. They're with the Reasons for Hope. And so he's written a book which I'm reading and enjoying as well. It's How to Think. Kids today are taught in school what to think, but not how to think. And so he'll have something to say about that as well. So tonight he's going to speak on the topic of creationism and intelligent design. What role does design play in our body, in the universe, and how does it compare with what evolutionists say happens? So with that, Juan, come on up.
Amen. Thank you, brother. Super happy to be with you guys again. I was here 4 years ago. I remember Pastor Rick, the church. We had an amazing time. And I'm looking forward to being here with you guys today, tomorrow for the conferences at the other locations, and Sunday back here in the morning to bring the word in all three services. So just happy to be here. I flew in from Miami. I hope you enjoyed the weather I brought with me today. Today was almost a South Florida day. Little colder than South Florida, but the sun, the blue skies, that's I brought that with me. So, but I don't know how long it's going to stay. It's going to stay. There we go. All right. So creationism and intelligent design. Man, I think we're all blessed, and especially in this part of the country. At night, if you live a little bit remote, when you turn off the lights and you step into your yard and you look up, what do you see? You see a show up there. You see the stars. You see God's handiwork. What you see is breathtaking. I've read in my studies extensively on these issues, and some of the most ardent atheists will say that the closest they come to believing that there might be a God is when they look up at the sky at night, or when they are in nature, in the woods, by a creek, when they see animals, when they see nature on display. It brings them as close as they've come to embracing the belief that there is a God. And the Bible talks about that. There's a beautiful psalm in Psalm 19. And Psalm 19 is a song. Psalms are songs. And this is a powerful song with incredible lyrics. It says, "The heavens proclaim the glory of God, and the skies display his craftsmanship." And this proclamation, this declaration of the glory of God is very peculiar, because it goes on to say that day after day, they continue to speak. Night after night, they make him known. It's a continuous proclamation of the glory of God. But what makes it even more peculiar, what makes it even more peculiar is that they speak without a sound. They speak without words. There isn't a voice that we actually hear, and yet the message is communicated. Their message has gone out throughout the earth, and the words to all the world. And if you just stop for a minute and think about the poetry, think about the profound thoughts that the psalmist is expressing to us, there's a language in nature that doesn't require words, that speaks of the glory of God. You know, I live in a big city. I live right by the airport. I live in a very noisy, crowded, big place. And traffic and horns and ambulances and police sirens and helicopters and you name it. Motorcycles, the noisy muffler cars. I mean, everything So when you step outside into nature and you disconnect from the noise, something happens. You start to sense something. There's a message being communicated. Paul spoke about this. Paul said to the Romans that man doesn't have an excuse to deny God's existence because his attributes, the things about God that we can't even see are clearly made known through the things he has created, through nature. And nature is powerful. And so what do we see when we look at nature in detail? What do we see? We see design. We absolutely see design. And something is happening in the world of non-believers. Something is happening. I see it. I see it in the academic world. I see it in the papers that are being published, in the journals. I see it in the scholarly forums that I attend. There's something happening. And what's happening is that even a scientist and biologists who have for the longest time denied any creation or any intelligent design, and the mantra and the standing foundation of modern biology today is that there's only an appearance of design. It appears to be design. That's the mantra. But thanks to Darwin and his development of the theory of natural selection, well, now we understand why it looks designed, but there's no designer. That has been the hill to die on for biologists for the last 100 years. But something is changing. You can't die on that hill anymore. Because as genetics advances, as the field of information science advances, as biochemistry and molecular biology advances, we are seeing more and more and more evidence of design that cannot be explained away by natural processes. And I'm going to show you a clip that is a bit dated. But this clip is showing you one of the most notorious atheists of our times, Mr. Richard Dawkins, who wrote The God Delusion and so many other books on atheism. An ardent atheist. I'm going to show you a video clip where he actually acknowledges that between you and I, there's a designer. There's got to be a designer. Now, when he starts to say that, you know it's because it's no longer possible to attribute what we see to unguided processes. It's impossible. Listen to him in his own words. He's being interviewed by Ben Stein in a documentary that came out many years ago called Expelled. If you've never seen that documentary, it's well worth watching, and it is not dated in its science. But listen to what he says, because I'm going to pick up on this incredible admission, recognition from one of the most notorious atheist biologists of our time. Here we go.
I suppose it's possible that you might find evidence for that if you look at the details of biochemistry, molecular biology. You might find a signature of some sort of designer.
I suppose that if you look at the details of biochemistry and molecular biology, you might find the signature of some sort of designer. And I'm like, wait a minute, Richard, are you starting to believe? Nah, the news isn't that good. But he's beginning to acknowledge that there has to be a designer. Now, where does an atheist go from there? Okay, you don't believe there's a God, but there is a designer. So where do you go from there? Well, you keep listening to him, and he's going to say that possibly some aliens did it. Some alien race, highly sophisticated, much more intellectually advanced than we are, designed life and planted it on earth. Now, what that tells me is very significant. Richard Dawkins does not have a problem with an intelligent designer. There's just some designers he would rather not believe in. That's a step in the right direction. That's a long step away from Francisco Ayala, the past president of the American Association for the Advancement of Science, where he says that the functional design of organisms and their features would therefore seem to argue for the existence of a designer. I mean, come on, it's hard to say no, but we're talking more than just complexity. We're talking about specified complexity. Because there's a difference here. The information in DNA is not just complex, it is specified and complex. Let me explain that. The information we have in DNA is not just complex. This is complex. You randomly put your finger on a keyboard and you just go brrrr. You're going to get a random set of letters like this. We would say that that is complex. Why? Because of it's highly improbable. Complexity is talking about something that's highly improbable. But when we're talking about specified complexity, we're talking about something different. It's information that performs a function. Instead of a garble of letters that are meaningless, although complex, we would have something like turn off the lights and close the door. I don't know you guys, but I loved when I was a child to eat that cereal that was called Alphabet. And I would play with the letters and try to spell words with the letters. Now, if I drop a box of Alphabet cereal on the ground, what do I expect to get? A garbled mess of letters. Some are going to be right side up, some are going to be upside down, some are going to be sideways. It's not going to spell a thing, I can promise you that. But that would be complex. The arrangement would be such that if you drop the box 10 times, you would get 10 different arrangements because it'll be complex. But when we're talking about specified complexity, we're talking about if I drop that box and all of a sudden I look down and it says turn off the lights and close the door. It's like, okay, wait a minute. Somebody arranged those letters to communicate something. Maybe my mom arranged the letters in my Alphabet cereal so that I would remember to turn off the lights and close the door when I left this morning. But that was not random. That was not unguided. And so what function does information in DNA perform? It tells us how a cell how to arrange amino acids to build a protein. And that process of building a protein, it's called protein synthesis, is a great example of what some biologists will argue only appears to be design. And I don't buy it, I'm sorry. It's not just the appearance of design. Protein synthesis, the manufacturing of protein in a cell, is anything but unguided. It is extremely well guided of a process, following very strict instructions. Now watch this video. You don't have to be a scientist to understand this. It's in lay terms, and it's a wonderful video that's put out for information purposes. It's a computer animation of how the cell manufactures a protein in your body. This is incredibly complex. Watch.
This animation demonstrates how the digital information encoded within DNA is used to direct protein synthesis. This is a DNA double helix containing the digital code which directs the cell in all aspects of operation. And here we see a protein complex called an RNA polymerase traveling down the DNA strand. As it moves down the strand, it carefully unwinds the DNA, preparing it for transcription. Inside the polymerase, we see a single-stranded copy of the original instructions being assembled as individual bases are positioned and added to the growing strand. A stop code marks the end of the protein specification, at which point this copy, known as a messenger RNA transcript, exits the polymerase and heads towards a two-part chemical manufacturing machine called the ribosome. While the messenger RNA moves towards the ribosome, transfer RNA molecules attach to specific amino acids in preparation for assembly. As the messenger RNA transcript passes through the ribosome, the process of translation begins. Using the instructions encoded on the messenger RNA as a template, the transfer RNA molecules align specific sequences of bases to corresponding amino acids, creating a protein chain. As this chain exits the ribosome, it is met by chaperones which prevent premature folding, while escorting the protein to a barrel-shaped machine called a chaperonin. This machine helps fold the protein into the precise shape required to perform its function. Although it is unclear how the chaperonin achieves this, we do know that accurate folding is essential in order for the protein to accomplish its intended function. Once the protein is complete, it is released into the cytoplasm to do its job.
That process happens hundreds of times per second in your cells. Let me break it down to you in a very simple way. DNA has the instructions for manufacturing protein in a section of DNA. All the protein varieties require specific instructions for each kind. So, how do you know which section of DNA to copy? How do you know which chapter to look at for the right protein you're going to build? Well, there's a librarian for DNA. The librarian is called the epigenome. And the epigenome tells the RNA molecule, okay, you're going to start copying from here and you're going to stop here. Those are the instructions you need for that one protein you're coming to manufacture. The double helix is unwound, and a copy is made of the instructions for assembling that DNA, and that copy is taken to the factory, and the DNA closes back up. The factory is called a ribosome, and that instruction set enters this factory, and from your body, the cell collects the amino acids it needs to build the protein. There's over 400 amino acids, but about 20 are used for building proteins. And having the right sequence is very important. You have to have the right amino acid next to the next right amino acid next to the next right amino acid as you make this chain. And in that factory, the chain is made of amino acids. When it leaves the factory of the ribosome, it's escorted by chaperones, because you don't want that strand of amino acids to accidentally fold, because it can be folded in thousands of ways, but only one way of folding it is going to work. Super complex. So in order for it not to fold ahead of time, the chaperones attach to it and keep it stretched until it goes into the chaperonin, where we have no idea how, but it folds it into the perfect shape to be the protein we need. Now, if at any stage of that process a mistake is made, the instructions were copied wrong, the ribosome attached the wrong amino acid, the chaperonin but folded it the wrong way, there is quality control at every step. And if it doesn't meet quality control, it's unassembled and sent back, raw materials, recycled, let's try again. That's the kind of process I'm telling you defies natural, unguided processes. This is a system that has been designed by an engineer 1,000,000 times smarter than we are. at a scale that we can't even see it, at a speed that is mind-boggling, with an accuracy that's incredible. And by the way, with one protein, you can't do anything. We're going to see that a little bit later on. I don't want to get ahead of myself. But you need to do this over and over and over again to build anything in the body. Proteins are our building blocks of anything in life. So Richard Dawkins wasn't always a believer in intelligent design. Way back when, one of his first books was called The Blind Watchmaker. You can see where he's going with that. Yeah, there's a watch that's designed, but the maker is blind because it's natural selection. In that book, he said, biology is the study of complicated things that give the appearance of having been designed for a purpose. That's what he used to think. He's changed his mind now about that. Now, the question we have to ask ourselves is, has the appearance of design really been explained away by undirected processes? And here we have to do a little bit of math, okay? Because math is going to help us figure out that this is a serious problem for unguided processes. Let's do the math together, okay? Can this happen by chance? Did amino acid arrange themselves into proteins by chance alone? No. And why? Because there's a problem we call combinatorials. How many of you like biking? If you have, in biking in Miami may be a little bit different than here. In Miami, if you stop to tie your shoes and you turn around, your bike is not there anymore. You know, it's serious. So we use these combination locks for biking with dials, and no matter where you do, you put that chain on and you spin those dials, because if you have 4 dials and 10 digits in each dial, from 0 to 9, that's 10 digits, mathematically speaking, you have 10,000 possible combinations. Just 4 digits, 4 slots with 10 options each is 10,000 possible combinations. So we're hoping that it's going to take the thief a little bit long to figure out the combination, long enough for us to come back and our bike is still there. But some people are skeptical and they say, well, 4 digits, I don't know, 10,000 maybe, I don't know. So, you know, there are people that are paranoid and they go with the 10 dial locks. 10 dials means 10 dials times 10 digits. That's 10 billion possible combinations. 10 billion combinations. And why am I using this combination lock as an example? Because the way an amino acid chain is built is similar. There are spaces, and for every space you have 20 options. So instead of 10 digits, you have 20 digits. And when you add the next number, it's got to be one of 20. And the next space, one of 20. And you see what starts to happen. If you have an amino acid chain of 10 amino acids, that's 10 sites times 20 amino acids. Now you're into the trillions of possible combinations. 10 trillion, 240 billion possible ways of arranging just 10 amino acid sites. So if we're going random here, we're throwing the dice and seeing if we can luckily land that perfect combination of 10 amino acids, it's 1 in 10 trillion, 240 billion chance. You're not going to get it by chance. The math tells you you're not going to get it by chance. But it gets even more complicated here, because most common proteins are between 100 and 150 amino acid sites. We were just looking at 10 sites. Go to 100 amino acids in a row and get each one the right one. Or 150. You want your mind to be blown? That little machine that makes the copy, messenger RNA, that polymerase, that's a protein built with 3,000 amino acid sites. To build that one, you needed 3,000 amino acids in a row. Each one is one of 20, and all of them have to be perfect, the right one. What happens when the average length is 300 to 400 amino acids? Most common ones are 100 to 150. But if you're going to average them out, 300 to 400 sites. Can you see what's going to happen to the combinations here? If you have a combination lock with 100 sites, 20 options for each site, you're now looking at 1 times 10 to the 130th possible combination. We don't have a word for that. The trillion is what, 9 zeros? 10 zeros? This is 130 zeros. Actually, so you see what happens here, right? The chance is impossible. Chance is not an explanation. Now, that's just getting them all in a row. Now, there's a left and right problem, and there's a right folding problem. When you put all of that together, geneticists have calculated that you now have the chance of getting one chain of 150 amino acids to build one protein, and to get it right is 1 in 10 to the 164th power. You starting to see what we see here? Chance is not a good explanation. The math destroys the possibility that this happened by chance. Impossible. This has to be guided with very strict, clear instructions of how this is going to be assembled. And you know, we think of these numbers and we can't imagine how big that number is. Come on. 10 to the 164th? Our mind doesn't wrap around that. If you were to count how many atoms, how many elementary particles are in the universe, protons, electrons, and neutrons, you know how tiny those are, right? If you were to count how many they are in the universe, in the known universe, scientists estimate that it's going to be around 10 to the 80th. That's how many in the known universe. And that's counting electrons, protons, and neutrons. No, I mean, 164th? That's insane. Messenger RNA, the one that I showed you that makes the copy, that's 3,000 sites. Times 20 amino acids, that's 1.23 times 10 to the 3,903rd power. That's 3,903 zeros. You know, it's funny because when I started to prepare this presentation, I started to do the math on a scientific calculator because I'm not that good. I need that calculator to do these calculations. And I was blown away because I had never seen a calculator do this. You know that the scientific calculators that we use in school, when you get to a certain number, they just call you dumb. And they say, hey, moron, what are you doing? Go back and do something productive with your life. When I started to plug these in, after a certain number, you know what the calculator tells me? Infinity. What's the answer? Infinity. In other words, put your calculator down and go do something with your life. After 309 zeros, that's the largest calculation you'll get from a scientific calculator. After that, it's infinity. It won't even give you a number. So I had to get one of my math friends who's a PhD in math to figure out some of these numbers for me because the calculator wouldn't do it. When the calculator tells you that this number doesn't exist because it's infinite, what are the odds of getting that by chance? And by the way, like I said, one protein, you don't do anything with one protein. You have to get lucky 250 to 400 times just to build a cell. Just to build the structure of a cell. So that luck has to repeat itself 250 times. And then you have one cell. One cell structure. What are you going to do with that? Nothing. You need to repeat that several thousand times. You see what's happening here? Chance is not a good explanation. All we have been talking about is one protein. How many proteins to build a cell? Between 250 functional proteins to produce a simple single-cell organism. By the way, that's to build the cell, but what about all the functions inside the cell? Those are additional proteins. Additional proteins. How many proteins are we talking about? Okay, Let me give you there was a group of scientists came up with an incredible study on, they were able to map how many proteins are involved in all the functions of a yeast cell. Yeast cells tend to be relatively small compared to many other cells, so they lend themselves to be studied more easily. And they found that just a simple yeast cell, when you talk about protein and how they catalyze to control all that happens inside the cell, you call this, by the way, the proteome. That structure is called the proteome, that controls, it's proteins controlling everything that happens inside the cell. A simple yeast cell has 60 million protein molecules. 60 million protein molecules. And each one of those 60 million protein molecules has a probability of self-assembling of 1 to the 10 to the 164th power. So you have to get lucky 60 million times to get a cell to work. I can stop there because I think we all know where that's going. And if anybody wants, I can share with you the link to the journal paper where they published this. And this is peer-reviewed, published, accepted. We know this is how it is. Okay? 60 million molecules. All of these millions of proteins cooperate to contribute to the life and health of the cell, responding to perturbations in the cell, playing a role to provide energy from nutrients, deliver cargo, translate, maintain genetic information, remove waste, replicate. Everything that happens inside the cell is controlled by the proteome. So chance is not a good hypothesis. Let me give you just an analogy. This is a great analogy that I didn't make this, another apologist did, but I love the video, so I'm going to share it with you, of what we're talking about, because again, we lose those numbers. They're too big for our minds to wrap around. So let's come up with an analogy of how hard it is to build one protein by chance. And here's a great analogy based on a grain of sand. Let's say you collect grains of sand, but you have that one grain of sand that's your favorite grain of sand. You love it so much you painted it red. That's probably the only red grain of sand in the universe. But man, you had it on top of the table and somebody opened the window. Wind came into your living room and you lost that grain of sand. How difficult is it to find that grain of sand? Because you know how tiny they are, right? Okay, let's watch this video. We're going to look for our grain of sand.
Here, we have one tiny grain of sand. It's been estimated that there are 1 million grains of sand in a half a cup. It would take 1 million half cups of sand to fill a swimming pool that's 6 feet deep and 30 feet in diameter. Now, if we took 1 billion of these pools of sand, we could fill Lake Tahoe in Nevada, which is about 22 miles long and 12 miles wide. Think you could find that original grain of sand we started with? We're not done yet. It would take about 1 billion Lake Tahoes to fill the volume of the Earth with sand. The probability of grabbing that original grain of sand out of the Earth filled with sand is 1 in 10 to the 30th power. It would take 100 million Earths to fill one sun with sand, and 1 trillion suns to fill our solar system, 10 trillion solar systems to fill 1 cubic light year, 100 trillion cubic light years to fill the volume of the Milky Way galaxy, and finally 10 billion Milky Way galaxies to fill the observable universe. Whew. That is a lot of sand. The probability of now randomly picking our original grain of sand from the entire observable universe is 1 in 10 to the 96th power. Still a far cry from our protein being formed at 1 in 10 to the 164th power, and even less chance of life evolving from undirected natural processes at the probability of 1 in 10 to the 340 millionth power. Starting to get the idea? Scientists generally consider anything with a probability of less than 1 part in 10 to the 70th power operationally impossible. And by the way, that calculation doesn't take into consideration the information that's stored in the cell, which directs the cell in all aspects of operation. That estimate is solely the chance of chemicals combining to form something living.
that gives us a little bit of proportion. So when I tell you that talking about unguided processes, explaining what we see in nature, no. That's why scientists today are looking for an intelligent designer. Just not God, some other intelligent designer. Let me give you the second example. That was information. Now, what about molecular machines? I think molecular machines, the machines we see inside ourselves, they are God's fingerprint all over us. They are a perfect example of God's signature. Now, not everybody's a fan. Not everybody's a fan. We still have the Tysons of the world that believe intelligent design is a philosophy of ignorance. Wow, I wouldn't even know where to begin to respond to that. There's attacks on intelligent design. You know, Michael Roos, now deceased, Florida State biologist, said, we find no empirical or conceptual reason whatsoever to think of intelligent design theory as genuine science. Really? Okay, apparently he wasn't keeping up to date with his journals because there is so much empirical data that shows intelligent design. So that's why Paul said it, and I quoted at the beginning, for since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. So for the next few minutes, I'm going to give you examples of machines, molecular machines that we find in nature. And you would never find the machine in our world and believe it happened by chance. Never. You would never argue that the engine in your car happened by chance. You would never argue that the engine in your lawnmower happened by chance. Let's get smaller. You would never argue that if you're a man, you would never argue that the motor that runs your electric shaver happened by chance. When you see a mechanical machine, you know that an engineer, or at least one or many engineers, spent a lot of time designing and modifying and testing and coming up with that complex machine. But what happens when we see these machines in nature? All of a sudden, oh, they happen by chance. Nobody built that. Darwin showed us how that was built. By chance. No, I don't think so. Let's talk about bugs. Bugs and gears, okay? Watch this short little video and it'll blow your way about, we thought we're so clever we invented gears. And it revolutionized machinery, and the Industrial Revolution was like, gears just made such a huge difference in our world. And engineers were all excited because they invented gears. No, you didn't. God invented gears. And put them in a scale that we haven't been able to see them until now. We didn't know they were there. But they were. They were. Watch this. This is actually amazing.
We don't typically ponder the elegance of bugs, especially the annoying ones. But scientists and engineers have come to realize they are actually mechanical marvels. Nothing we humans have ever built even comes close. In fact, a growing field of engineering called biomimetics is making breakthroughs by mimicking biology. For example, studying the eyes of flies led to the development of advanced optical sensors. The physics of dragonfly wings allowed increased efficiency of wind turbines. Cockroach mechanics paved the way for increased agility in robots. A honeybee algorithm helped to optimize the internet. And the tiny plant hopper is helping scientists to maximize the strength and rotation of gears. Those perfectly precise, interconnected drivers that have transformed machinery for centuries. Well, it turns out that biology is far ahead of our engineering. The plant hopper launches like a rocket. and can jump more than 100 times its body length. That's like an Olympic long jumper hurtling across not one, but 2 football fields. Using special cameras, scientists at Cambridge University discovered that the plant hopper coordinates the motion of its legs with these incredibly precise gears. Making long leaps accurately requires that the legs be in perfect sync. If one leg flexed even a fraction of a millisecond before the other, the insect would lose power and tumble erratically. As one leg begins to move, the interacting gears start the other leg too. With the teeth engaged, the gears spin at a whopping 50,000 teeth per second, and the bug is propelled with maximum power and coordination. As science learns more about the structures of living organisms, we seem to be finding limitless examples of mechanisms that are both precise and purposeful, both remarkably configured and beautifully functional.
Tomorrow, tomorrow morning, my first talk in the conference we're doing tomorrow is on biomimicry. It's exactly on how scientists today are learning from nature how to solve our problems, how we're copying God's design and using it. That's our first talk tomorrow. So I'm not going to go there, but I want you to think about the gears for a minute. Can somebody actually believe that these gears happen by chance? Gears are engineering at its best. This plant hopper jumping 100 times its body length. 50,000 rotations per second of these gears to launch it. You're talking about incredible engineering at an incredible size that up until now we had not been able to see because we didn't have the microscopes and the technology to be able to capture it on video. And now we do. Now, I don't know about you. Anybody here like boating? I'm in Miami, man. We boat. We don't hunt, we boat. Okay? I have a boat, and I love going fishing, and I love boating. And you know what's most amazing about these boats is those outboard engines. They are just amazing. You go to the boat show and I salivate at these boat shows. Just watching these amazing engines. They are designed to push maximum power, fuel efficiency. They can make those boats fly, okay? And so these amazing machines, nobody would think for a minute that these machines are the product of just random chance, or they self-assembled, or natural selection somehow built these machines. Of course not. And you might ask yourself, well, how many engines do you need in a boat? Like, come on. Like, most boats like mine have just one engine, and that's more than enough. But people like to race, and they like to speed, and they like power. So on some boats you'll see 2 engines, 3 engines, 4, 5, 6 engines. That's an exaggeration. That's 6 400 power engines. That's 2,400 powers. I mean, you gotta be strapped into those seats, or you're going to be left behind when the boat takes off. You're going to be sitting on water, not on the boat. It's going to fly right out from under you. Why am I going there? Because we have an outboard engine in our body. Well, not one. We have hundreds of them in our body. Because how do bacteria get around in the body? Through the bloodstream. And how do they navigate the bloodstream? They have an outboard engine. That was one of the discoveries that launched the modern intelligent design movement, when we figured out that there was something called a bacterial flagella, an outboard engine that pushes bacteria through the body. That was incredible. And it has all the parts that you would expect to find in an outboard engine. Watch this short video that explains a little bit, and then I'm going to show you what we recently discovered that's even greater than that. Here we go. Watch this short video.
Perhaps the most amazing propulsion system on our entire planet is one that exists in bacteria. It's called the flagellum, a miniature propeller driven by a motor with many distinct mechanical parts, each made of proteins. The flagellum's motor resembles a human-designed rotary engine. It has a universal joint, bushings, a stator, and a rotor. It has a drive shaft and even its own clutch and braking system. In some bacteria, the flagellar motor has been clocked at 100,000 revolutions per minute. The motor is bidirectional and can shift from forward to reverse almost instantaneously. Some scientists suggest it operates at near 100% energy efficiency. All of this is done on a microscopic scale that is hard to imagine. The diameter of the flagellar motor is no more than 5 millionths of a centimeter. The bacterial flagellum is one of many molecular machines that scientists have discovered in the last several decades, including energy-producing turbines,
We're going to see those.
information copying machines,
We already saw that.
and even robotic walking motors.
And we're going to see that in a minute.
The origin of these exquisite examples of nanotechnology is a mystery that has generated heated controversy among biologists over the past 2 decades.
An engine. The bacterial flagellum is an engine. And it's so tiny. It has all the parts of an outboard engine. And we didn't build it. We didn't design it. We didn't even know it was there until we just figured it out. And it's been there for how long? Since man was created. Thousands of years ago, God designed an outboard engine. And we thought we were clever discovering and building engines and outboard engines. And we thought God had beat us to the punch thousands of years ahead in the design of that. But that one engine, as complex as that is, Japanese scientists discovered a bacteria, a special bacteria. They published it in a very reputable scientific journal, PNAS. And this bacterial flagellum has a very peculiar distinctive. It doesn't have one outboard engine. It has 7 outboard engines. And they are all working in perfect conjunction. They discovered a bacteria in our body that is propulsed by 7 bacterial flagellum working in perfect synchrony. Because, by the way, if they're not working in synchrony, it's not going anywhere. Think about that for a minute. Not just 1, 7 on one bacteria. The complexity of this is absolutely mind-boggling. But you know what else is mind-boggling? The scale of it. The size of this. See, we see these animations, we see these graphics, we see it blown up on the screen. But what's the real size of this? You know how these nano machines are measured? Nano is called a nanometer. You want to know how? Let me show you how big, or not big, a nanometer is. So if I had, I would, but I don't. So I would ask you, if you have, grab one of your hairs. Grab one of your hairs, ladies. Just one, not 2 or 3, just one string of hair. And ask yourself, okay, how thick is that? How thick is your hair? How many nanometers thick is your hair? Well, if you're measuring your hair in nanometers, your hair is huge. Huge. It's 100,000 nanometers. One string of hair is 100,000 nanometers wide. That is huge in the world of nanotechnology. Because most of the things we're looking at are 10 nanometers, 100 nanometers, not 100,000. The scale, we couldn't even see it until we invented the scanning tunneling microscope. That's the microscope we use to see some of this stuff. It's the size of a room. We need to build something that big to be able to see something that small. It's incredible. But the things we are seeing inside the cell have unlocked, have opened up the world of intelligent design, and there's no turning back. There's no stopping. Ladies and gentlemen, it is the greatest time in history to believe in intelligent design and creationism. The greatest time in history, because we have unlocked, we have opened the door to things we had never seen or imagined before inside the cell. Some of the most amazing discoveries we have discovered. I'm going to show you two machines, two more molecular machines. The first one I'm going to show you is how you get energy. You know that everything that requires energy needs to be charged or fueled somehow. Your car runs out of energy. If you have an electric car, you have to plug it in because it runs out of energy. If you have a radio, you need batteries or you need to plug it in because it doesn't work unless it has energy. And what happens to batteries? Batteries die out and you got to recharge them, right? But have you ever wondered why we don't have to connect to the electricity at night? Why we don't have to plug in? Why we don't have to replace our batteries? How is it that we don't need to recharge our energy? How is it that we continuously consume energy? We run marathons, we compete in sports, we're up for 12, 15, 18 hours a day, running, walking, doing, consuming incredible amount of energy, and we don't run out of energy. Oh, because we have the engineer that designed us bypassed all of that, plugging in stuff. That's our technology. His technology is different. See, he built into our cells a system where the batteries, when they run low, they're sent to a recharging station in our cell. This recharging station charges the battery, sends it back to give you some more energy. This happens many times through these molecular machines called ATP synthase. These are molecular turbines. There's tons of them in every cell, and all they do is produce energy and renew energy and renew energy in our lives continuously. Let me show you a video, a computer animation of what this looks like. Again, at a scale that we can't see with the naked eye. But it's happening, and it's happening incredibly sophisticated. Watch this incredible machine at work.
It's been called one of the wonders of the molecular world, an amazing nanoscale machine. ATP synthase is a high-tech micromolecular power generator inside the cells of your body. It generates adenosine triphosphate, or ATP, an energy molecule that provides fuel that every one of your cells needs to function. Without this fuel, your cells will cease operation, and so will you. ATP synthase works like a rotary engine. The barrel-shaped rotator is composed of 10 to 15 protein parts called subunits. The rotator spins around, transmitting mechanical energy into the drive shaft of the machine, which helps make ATP. This drive shaft has a specially placed bump that opens and closes parts as the drive shaft spins around. This bump opens special protein subunits on the bottom of the machine. When the bottom subunits open, a spent energy molecule called adenosine diphosphate, or ADP, enters the machine. The mechanical motion causes the ADP to bind with an additional phosphate group, creating the ATP energy molecule. And the ATP drifts off into the cell, ready to power some biomechanical reaction. The ATP synthase machine has many parts we recognize from human-designed technology. A rotor, a stator, a drive shaft, and other basic components of a rotary engine. The ATP synthase is one of thousands of elegantly designed molecular machines inside your cells that make your life and all known life possible. ATP synthase. An example of intelligent design.
So you have a spent battery, ADP, it's a diphosphate, means it's spent. A good fully charged battery is a triphosphate, ATP. So there's a missing phosphate group, that's what you consumed as energy. So the diphosphate, ADP molecule is sent to the turbine, And in the turpentine, it's an additional phosphate group is added to it. Now it's a triphosphate, and it's sent back to work, fully charged battery. And it's constantly happening over and over and over again in all these turbines. Empty battery comes, new battery charge comes out. Empty battery, new battery, empty battery, new battery, all day long. That's why you and I don't need to plug in at night. And of course, all of this is based on the consumption of food and water. We eat food and we drink water, and the body is designed to extract from our food and water what it needs to produce the energy that our body needs using these kind of machinery. And you want to tell me that it all happened by chance? Wow, chance is becoming an incredible designer. I think we should change the name of chance to God, because the design is just absolutely incredible. We think we're so sophisticated because we've discovered some things. You know, we haven't even been able to map an entire cell yet. Meaning we don't know what happens in every section of a cell. We know a lot, but there are still sections of cells that we don't know what's happening. Let me show you a map of a cell. That's a biochemical map of a cell. Okay? Let's zoom in on that circle in the middle, because I can't read that and you can't read that. So you zoom in a little bit, and you zoom in a little bit more, and you're seeing there everything that happens inside a cell. And there are sections of the cell that we don't know what happens. We still haven't figured it out. But what we already know is incredible, incredible. Does that kind of complexity, let me go back, I'm sorry. Does that kind of complexity look to you like it just happened randomly? All that wiring that goes on in there, all that electrical work, all that incredible amount of information, all the processes, all the proteins, all the mechanisms, all the factories, all the workers. Oh, the workers, we're going to go to those now. Because the cell have employees. What's a factory without a worker? It's not going to produce anything. So, it has workers. I'm going to show you the workhorse of the cell. It's called the kinesin. And the kinesin is just one of those things that, again, we have recently discovered it. Why? Because we can now look inside and see what's happening in the cell. This will blow your mind. I want you to listen carefully, because you're going to see design like you've never seen before inside a cell. Listen to what happens, because as it's describing it fast, but the things it's saying are like, really? Really? That too? Oh my God, really? Like, it's incredible. It's mind-boggling. Here we go.
Cells are full of specialized components that perform functions vital to their existence. But how do these components get to the right locations inside the cell to perform their functions? For larger components, a transportation system is needed. Meet the kinesin. Masterpieces of microengineering, kinesins are miniature motorized machines that carry cargo from one part of the cell to another, walking along self-assembling highways called microtubules. Known as the workhorses of the cell, kinesins have 2 feet, or globular heads, that literally walk 1 foot over another along the microtubule, pulling their cargo to its destination. Each foot possesses 2 special locations called binding sites that interact with other molecules. One site attaches to the microtubule and the other binds with ATP, the energy molecule of the cell. When one foot binds with ATP and uses its energy, the foot flips over, resulting in the walking motion. Each foot has a short neck which is connected to a strand of a long coiled stalk. At the end of the stalk is a fan-shaped tail which holds tightly to the cargo being transported. Kinesins can carry cargo that are many times their own size. Sometimes a kinesin is in danger of getting stuck on the microtubule highway because of blockages caused by other cellular components. To get around such obstacles, multiple motor proteins may be used to carry a single piece of cargo, together providing enough force to break free. Kinesins typically walk away from the center of the cell and toward the cell's periphery. The kinesin's 2 feet work together efficiently, with one foot holding fast to the microtubule, while the other releases itself and takes a step forward. This coordinated stepwise movement allows kinesin motors to walk as many as 100 steps per second, moving about 8 nanometers with each step. When not carrying cargo, kinesins can shift to energy-saving mode to conserve fuel until their next job. The kinesin plays a vital role in many cellular processes, not just transporting materials, but also aiding cell replication. The walking kinesin molecular machine, another example of intelligent design.
This is a walking, I did a tour today of the Amazon warehouse, and I was blown away by the robotics and those robots that transporting and pushing things around. And I'm saying, there was somebody that beat us to that. Yeah. These machines carry cargo from one place to another, and they walk on a self-assembling highway. Did you catch that? They're going from one place in the cell to another, and there is no highway there. The highway self-assembles as they're walking. As one foot or one cellular globule goes over the other, and it pulls. And if it's too heavy, you get assistance. You may have 2 or 3 kinesin pulling the same cargo to get it to untangle and get to where it's going. And when they're not pulling cargo, they go into a rest mode so they don't consume energy or waste energy. And they're ready for their next job. And we want to talk about chance. And we are just scratching the surface, ladies and gentlemen. God is an incredible designer. And we have yet to discover. I could almost, as sure as I'm here, I could tell you that if I would do this same talk again here 4 or 5 years from now, I would be able to show you another 6 or 7 machines that we have discovered. Because that's how this is going incredibly fast. We're finding things that we didn't know were there. And learning more about these things. And it's incredible. It's incredible what we're learning. So that's what I wanted to share with you today. I wanted to share that creationism and intelligent design go hand in hand. Because creationism tells you that the earth and everything in it is not the product of some random explosion and unguided processes. It's the handiwork of a creator. And we know this because everything in creation has incredible design. Intelligent design. So the intelligent design in the natural world points to an intelligent designer. Not to an alien, but to the God, the almighty, all-knowing, all-powerful God that we serve. And when we see this, we are left, as Paul says, without an excuse. It takes total blindness or purposeful neglect to see this and still deny that there's a creator. And yet, I will do this talk, and I have done this talk on secular campuses. I did it recently at a school of medicine in Peru. I did it at a chemistry and physics auditorium in another city in Peru. I've done it in medical campuses in Colombia. Talking to doctors, future doctors in medical school, and showing them intelligent design. And I will still get the professors to stand up and challenge me and say, no, that's not true. This is all unguided because natural processes, because Darwin, and I'm like, wow, how blind do you have to be? How blind do you have to be? But serious scholars, serious scientists, every day are joining the revolution that, you know what? The old system, that old model, it doesn't work. It doesn't work. Darwinism today is called modern synthesis. The modern synthesis doesn't explain what we need it to explain. On the contrary, it creates more questions than it answers. We need an alternative theory. Many are not willing to embrace God as the alternative theory. But nevertheless, creationism is living right now in amazing times. So don't be ashamed, don't be embarrassed, to stand firm in what the Bible says. The Word of God says, in the beginning, God. And that is the answer. And that explains best what we see in the natural world. So we're going to stop there, and we're going to open it up for some Q&A. And so Brother Heinz has got a mic. He's going to walk around. If you have a question, let him know. He'll bring the mic to you so we can record the question as well as the answer.
Yeah. Okay, let's give him a hand for the presentation. And if you do have a question, put up your hand so we can hear the question as well as the answer.
In the back.
I see one back there, two back there.
The simple question about aliens is, okay, if aliens came and planted us, where did the aliens come from? You're just putting the question off somewhere, right?
By positing aliens, you're just pausing the question back one layer. Where did they come from? They also needed a creator. So.
Okay, another question.
This isn't really a question, it's a statement. My brother raises bees, and sadly he's not a believer. And he just picked up 100,000 bees. And in those bees, they have what they call bees that helpers that actually groom other bees and get rid of mites that the bees have. And this has been just created in, I don't know, the last few years. But him not being a believer boggles the mind.
Bees are phenomenal little animals. They are amazing. I don't know if you know this, but a bee has a way of communicating with other bees, exact addresses, geographical locations of where they find honey, where they find sugar. How do they do that? It's been studied. They'll go out and they find a bed of flowers with a lot of sugar, and they will return to the hive and share the location of it with other bees. They will stay in the hive, and the other bees will fly out directly to the spot that they were told. How do they do that? How do they communicate longitude and latitude with precision? They have a dance. The bees have a dance that they do for the other bees, and that dance communicates latitude and longitude. They understand it, they communicate it, they go out there and they find the exact same flower bed. We are scratching the surface of God's design. Bees are amazing.
Yeah. Another question here.
I don't know how much this is directly related, but I think we're all the same. And you mentioned that. I was just going to say, like, the food and the water that goes into our body. I don't know if there's even a specific answer, but is cancer cells always in the body?
That's really a great question.
Or disease, any kind of diseases.
Yep.
Are they there and they're somehow woken up?
That is a wonderful question. The question is, because the food we eat is what gives us nutrition and stuff, the question is, are cancer cells or sick cells or just bad cells, bacteria, is always in our body? Okay, first of all, we go back to the Garden of Eden. Adam and Eve's body was perfect. Were perfect. They did not have cancer in their bodies. They did not have any deadly disease in their bodies. But they had bacteria. And they had viruses. Because bacteria and viruses do incredibly important jobs in the natural world. We focus on deadly bacteria and deadly viruses, but for the vast majority of bacteria and viruses, they're not deadly. They're actually very much necessary. Bacteria are what allow us to digest food and extract from the food the nutrients that we need. Without gut bacteria, we can't derive nutrition from the food that we eat. So those are good bacteria. That's always been in our body. That's God's design. They have a job to do. Now, where does cancer and all of these other things come from? Well, there's a lot of theories and a lot of speculation, but I think most doctors will agree, and most scientists will agree, that the stuff we eat that is not natural, that the body is not built or designed to process, anything natural that you consume, the body knows what to do with it. Because the natural world was made for our provision. But when we start adding artificial and tampered with products, that alters our cells. So one of the first things that a doctor will tell you when you're diagnosed with cancer is stop eating sugar. Stop eating partially hydrogenated oils. Stop, and why? Because we know that all of these foods contribute to the health of cancer and to the cells. So in a way, we have poisoned ourselves, but in another way, our defenses are not what they used to be because our bodies are deteriorating because of the fall. The fall began to deteriorate our bodies, and even after 6,000 years of deterioration, we still have an incredible body that does incredible things, but it's not what it was designed to be initially. It has been corrupted. So.
Another question here.
Sorry, I was just curious, like for when you go to like a university, you do this presentation. I think as believers, it's overly clear that there's intelligent creator at work. What's the response that you get for someone who's going to argue, no, there's not? Is it literally that it's just chance, or I just find that confusing how you couldn't see like what's at work here.
Yeah, typically what the answer we get, it doesn't address the evidence that I show, because you can't address that and dismiss it. The typical response is, you're talking about religion and what we do is science. And so what are you doing here in the university? Why are you talking to us scientists about religion? Keep religion in the church. What we do is science. And my response is, which part of the ATP synthase is not science? Which part of the kinesin that I just explained is not science? Which part of protein synthesis that I just explained is not science? Or did I get the science wrong? Please correct me. Am I wrong in my science? No, I gave you science. Now your job is to explain to me how that is possible without an intelligent designer. And we'll go back and forth, but that their point is, this is not science. They dismiss it. They don't engage. You can't engage with that. And if somebody engages, they'll engage with arguments that have been refuted so well already. Sometimes when you show the oldest of these discoveries is the bacterial flagellum. So scientists have worked really hard to try to figure out how to respond to that. So they'll tell you that the parts of the bacterial flagellum are borrowed from other mechanisms in the cell. So it's not that an engine was designed, but that this part happened to come in contact with that part from that other thing, and that part, and all of a sudden you have a bacterial flagellum. It doesn't answer the question, because who designed the parts? Okay, the rotor, you find the rotor in 4 machines inside the cell. Okay, but where did the original rotor come from? A rotor doesn't just design itself. Gears don't just design themselves. It doesn't answer the question. Plus Darwinism and evolution tells us that for these mutations to work, they have to be beneficial. And so an outboard engine, like a bacterial flagellum, requires 32 protein parts. And for it to work, all 32 parts have to be built, assembled together at the same time for it to work. So the body is not going to hold on to parts until you have enough to build an engine, because those mutations would not be beneficial and they would be discarded. So you cannot explain a natural process that assembles a bacterial flagellum. It doesn't exist. So there'll be that kind of answer or pushback, but it's pushback that has already been clearly refuted. So good question. Thank you.
Okay, well, we'll wrap up the formal Q&A. It's 8:30 now, and,
Okay.
but you'll be available to answer questions at your table.
I will be at the
Yeah.
table. We have some resources and be glad to answer any further questions. Thank you so much. God bless.
So with all those molecular engines in your body, can anybody feel them moving? No. Good thing, because there's thousands of them. Okay, well, again, thank you for that presentation. And next month, we have Tom Hoyle. Tom Hoyle's been to some of your churches over the years. He's been doing apologetics for a long time. He's also got a degree in apologetics, just like Juan does, and Phil Fernandez. So there's a few well-educated people in apologetics there. So on the back table, there are flyers for the upcoming events. The two that you want to be aware of is the one tomorrow morning at Faith Bible Church. It's downtown Arlington. And then Saturday night, also in Arlington, on Olympic Avenue, is Lifeway Church. So that's at 6 o'clock, and then the one in the morning starts at 9. So we have 2 lectures, and he'll have time for some other Q&A after that. Okay, there's some refreshments out there. There's also resources. One of the books that Juan has written is How to Think. Okay, you are taught, your children are taught what to think, but we really need to how to think logically. So he's got that book on his table, and there's some other booklets there as well. Now, in the Apologetics Forum, we have books out there on apologetics, a lot on creation versus evolution, and we also have some DVDs. But the DVDs out there, you'll notice there's a sign. You buy one, and you get the second one free. We have a small table of DVDs left there, so take a look at that. Juan mentioned the Expelled DVD that is put out by Ben Stein with that interview with Richard Dawkins. We actually have, I think, 2 or 3 of those DVDs left on the table. So take a look at that if you want to get some more information on that. So again, we thank you for your being here and for your support of this ministry. And that allows us to bring the speakers to churches like this, but also to schools, and to do a special youth night for the kids. So we thank you for making that possible. If you want to contribute to that, there's boxes at the back, chairs there. You can add to them for donation, or if you'd rather do it online, just hit the donate button on the apologeticsforum.org, and you can use that as well. Okay, so that's all I need to cover at this time. So I'm going to just close in a word of prayer, and then we'll be dismissed. Father, we come to you again. We thank you for the folks that came here to listen to Juan. He's a lot of knowledge, and he knows your word, and he knows science and apologetics. And we thank you for giving them those talents and to combine them and give these messages at many different countries in the world. We just pray that you continue to bless his ministry, be with him as he does more talks on Saturday morning and Saturday evening, and then back here at the church on Sunday message. We just pray for good results from all that. In Jesus' name we pray. Amen.